Okay. Difference of two squares theorem.
What's the theorem?
When we use the radical sign to indicate, I'm reading from my notes here. When we use the radical sign to indicate the square root of a positive, we are designating the principal or positive square root. Basically, in this book, that means that, right?
Sure.
But in reality, isn't the square root of 4 2 or negative 2?
Why?
Wait.
Think about it.
Yes, it is.
Because, think of this.
-4.
2. -2 times -2 makes +4.
So isn't that
Would be
really
easy.
true?
Yeah.
So why don't we just do that? Why don't we always do that?
We're lazy.
Because
Because
2
we're
is
nice to you. We're spoon feeding
Yeah.
math to you until you get older.
Then you have to write
Then
everything.
when you get older, guess what? You do this for your answer, and you're like, and your teacher's like, wow, Isaac or Carly, good job. You got 100% on your test, but really, I had to drop your grade because you forgot that.
Oh,
We only got 50% right,
wow.
or you get it marked wrong. Painful. Now, this book, though, wants to clarify something for you. That's your future. That's your future nightmare. Right now, though, the book is telling us that if they want you to remember to use the negative square, they would write this. They're going to write this for you.
-4. Square root 4.
So they want you to see either they give you this or they give you this.
Okay.
So they're designating it for you. So you don't need to write this every time you see a square root. I don't know if I believe in that. I don't know if they're just giving you, full steps. But for now, we'll just say, okay, book, we'll do it that way. And then my book says, let's explore something. Or my notes do. If x squared equals 4, then, of course, now we look at it this way. If x squared equals 4, what could x equal?
X squared.
It's negative.
It could equal 2, right?
Yeah.
And this is where we get stuck. We have only half our answer. We're half wrong or half right.
Both.
Yeah. So, is this done? Is x equal 2?
Sort of.
And
Not really.
equals x
Now
or
it's-
-2.
Now
I
it's
mean,
done.
2 or -2.
Yeah. So now let's explore something else. You don't have to write anything yet, I just want you to watch. Let's say p squared equals q squared. Can you guys think of a situation where that's true?
2 squared equals.
What could p equal and q equal for this to be true?
I think it's true. It could not happen.
No, it couldn't happen. Could it? Because
It could be like -2 and 2.
Okay, would this work? Would this work to make this a true statement? Is 2 squared? Which is 4?
Oh! Yes!
Yes.
That would work.
Good, Isaac found one.
Okay.
Does it work for anything else except for when you have opposites? Or they both could have been 2, right?
Yeah, but then why?
You
would
can have 2 letters
you
equal
just
the
have
same
it-
thing.
Yeah.
But then why wouldn't it just say p squared equals p squared?
Yeah.
I don't know.
Right, but we could substitute them in. We've done substitution before. Can we think of any other situation where that would work, where these aren't either the same or opposites?
Maybe.
So we could stay here for about 3 hours and realize, no, we can't. I can't think of one. The book says we can't think of one, so let's just cut it short. Now, let's play with this algebraically. What if we took away, what if we get them both to the other side? Do you see why I did that? Because I want that to equal 0.
Oh yeah.
Oh.
Then you can factor it.
So then this says this. Ooh, Jordan's on to this. So do you agree with that so far?
Yeah.
Okay, do you remember we can factor something like this?
P minus.
P minus Q,
Q.
P plus Q. Woohoo!
Is that true?
Yes.
Yes.
And then P equals Q. And then
Yeah.
P equals -Q.
Yes. Oh my
Got
goodness,
this.
you guys are awesome today. That is called the difference of two squares theorem.
The difference of squares theorem. The difference of squares theorem.
Okay.
Okay. The
Yeah.
difference of two squares theorem is a box in your book. So when I see a box, it usually means something important. And this is the logic. They're going to write it in a statement like logic. It says, I keep trying to stick that on the board. If, so Jordan, you're going to have to look up here because you don't have a box. If P and Q are real numbers, and if, so we have like two if P's, right?
Mm-hmm.
And if P squared equals Q, so there's our if statement, right? This is, what's that called in logic? Have you guys talked about that?
Logic.
Yeah, is it
Logical.
hypothesis conclusion?
I don't know.
Oh.
We haven't done that
You
yet.
haven't gotten there yet. Okay.
We just have if-then statements or
Okay. So
either or.
You'll find out in math, if-then statements are used all the time in geometry. And
If she went to
anytime we have the word theorem involved, anytime you see this, this is an if-then statement. And your geometry book is full of theorems. And we're doing a theorem right now in your algebra book.
Oh, good for us.
So what's the conclusion of this statement here? If P and Q are real numbers, and if P squared equals Q squared, then P equals or P equals
Or Q equals.
or Q. Yeah, so what should we write here? What does P equal?
P equals
Then
positive.
they're either the same number
Or they're
or
not.
they're opposites. Opposites mean one of them is the negative.
Woohoo. And now we start example 1.
Okay, example 1. Oh, look up here though. It's very important to realize that in the beginning of the algebra book, the plus minus sign,
Yes.
plus or minus, that's the plus minus sign,
Yes.
Ah.
okay?
Hmm.
Arises only in the solution of quadratic equations, meaning if we had this, then m equals, you know?
Positive or negative 3.
No. M squared equals 3, so m can't be equal 3.
Oh.
See?
Yeah.
Get it?
Yes.
Yeah.
Right. So, and they said, why did they say no, no, no? Oh, they're saying this for now, does not equal. Then they said in the book,
No.
no, no.
Why?
I know, I'm kind of like
That's
trying to understand why, because
What is going on?
in this case, no, the square root sign is used to designate only the positives for you guys now, unless it was this or this. So
Why did
unless they have this, they're gonna say no, 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 no.
Why?
No,
Um,
no.
No.
in this case, there is no equation to be solved. The equal sign is written by us to show that square root of 9 has a value of positive 3. If we wish to designate the negative, we would say negative square root of 9 equals negative 3. That's how the book's going to work today, or this year. So now the question is, p squared equals 16.
Here we
And
go.
I already did it. I solved it for you.
Yeah.
P equals, so what does that mean? Do you guys remember that we
P
can take the square root of both sides,
Plus
right?
Yeah.
minus
P equals 4.
4.
Or,
Or negative.
4.
because when it's that way, we are designating, because are we saying square root of 16, or are we saying p squared equals 16? So p can be these two. So instead of writing p or negative 4, you guys like to shortcut things. How about that?
Woohoo.
Yeah.
Okay. So now what if we have, so it's equations that they want us to use the plus or minus sign. How about that? When you have an equation. So P equals,
-4. No. What? What am I?
you guys see on example 2 up here?
Yes. No.
This is
Yes.
an equation, right?
We are on page 2.
Also not. Okay. I'm like what?
So this is an equation. When we use an equation, we use plus or minus. That's our rule. So Jordan,
Yeah.
the answer is plus or minus what?
I don't know.
Square root.
I don't know what the square root of 41 is.
Just write it.
Oh.
Because it's a irrational number. It's some decimal to the never ending. Okay, and the last one is k squared equals 13. K equals plus or minus 13. Square root of 13, sorry. Now, your practice is the easiest in all the world, right?
Whoa.
Just gonna do it right there.
Yeah, let's do it. Let's do it!
Yeah.
P equals 13.
Yes, you guys memorizing your squares yet? Is it 13 plus or minus? Oops.
Plus or minus 13.
13.
Well, that is 13.
Yes, it is.
I don't go up to 13. Let's go
You
to
need
12.
to. It's time.
It's time, Isaac.
26, 30, 42.
Okay, B is
9,
plus or
39.
minus.
52, 42.
There are your answers up there.
Woohoo.
Unless it's a perfect square, just leave it like that.
Okay.
Okay.
Are we done now?
Congratulations. You can go ahead and turn me off.